Understand the differences between Imshow, pcolor, and pcolormesh, and when you should use each of these plotting functions when you're making your matplotlib plots. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to talk about a couple of different plotting functions in Matplotlib, namely Imshow and pcolormesh, though we'll throw pcolor in there as well. This is a common question that we get is, when do I use different ones of these? Why would I use different ones of these? And what exactly is the difference here? So we're going to make a little simple example and use it to illustrate those differences. And that's really the best thing you can do in Python when you're trying to understand something, is make a little array, say 3 by 3 of data, and start playing with it to understand how that functionality works. Because even though you read the documentation, you might still need that experience. So let's go ahead and do our imports. So I'm going to import matplotlib.pyplot and numpy. And we'll use our matplotlib inline magic so that our plots display inline in the notebook. Next, I'm going to create some fake data. I'm going to make an X array. And there are ways to do this with a lot less typing, but in this case, I'm going to go ahead and type it all out, and I encourage you to as well, because I think this is a good way to understand exactly what we're looking at here and what's going on. So there we have an array of X locations of our data. So the data points are 0, 1, 2, 0, 1, 2, 0, 1, 2, and X. For Y, we will do something very similar. So that first row of data are all at Y of 0. The next row are all at a Y of 1. And the final row are all at a Y of 2. And now we can make some Z data. I'm just going to put a nice pattern in here that we can easily visually recognize. I'm going to go up by a half for each value, and then I'm going to repeat a value at the beginning of the row. All right, so there we have our data. Now we've used Imshow quite a bit, even in the past few weeks. So let's go ahead and make a plot of these data with Imshow. I'm going to create my figure and my axes objects using the subplots method. And then I'm going to call Imshow with our Z data. And to make sure everything looks as we would expect, I'm going to set aspect to be equal. So there we have our data. Notice the lower values are in the upper left corner, just as they are in our Z array. That's because Imshow, by default, uses that upper origin. If we look at its documentation, we can eventually find that scrolling through here. So upper and lower. So the 0, 0 point of an image, whether it's going to be in the upper left or the lower left, if we change that to lower, then it flips, and that's a little more like a traditional data plot would be, not an image plot. And we've seen this in past MetPy Mondays as well. So let's try using pcolormesh. So I'm going to create a fig and an axis, same as above. And now I'm going to call pcolormesh X, Y, Z. We didn't have to give X and Y to Imshow. Imshow is going to assume that things are on an evenly spaced grid. In fact, they need to be. Whereas with pcolormesh, that's not the case, as we'll see. So let's go ahead and set the aspect ratio to be equal. And here you might think, well, I'm probably going to get the same plot. But we don't. We get a portion of the plot. And this starts pointing towards exactly what's different between Imshow and pcolormesh. Imshow, as I mentioned, assumes that everything is on evenly spaced grid. And yes, we can set extents so that these values are different than what has been assumed here. But if you notice, 0, 0 is in the center of this square. 1, 0 is in the center of this square. So these are centered, discrete data points, and we're drawing a box around them. pcolormesh, on the other hand, let's look at the documentation. All right, so we've got our 2D array that's going to be color mapped. X and Y, coordinates of the quadrilateral corners. So what we're doing is we're taking the value from our data array Z at index ij, and we're mapping each corner of it. So it doesn't have to be a rectangle. It certainly could be a rectangle, but it doesn't have to be. So let's go ahead and create a new X and Y array that's going to plot all of our data. So remember, we're trying to specify the coordinates of each corner. And we could go ahead and shift everything by a half. I'm just going to add one more value onto the end. We're going to create our array for X, 0, 1, 2, 3. And we can copy that. Notice this time I'm making 4 rows and 4 columns because we have to specify the corner. So we've got a data point that sits here, 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 and here, here, here. Sort of where you see a comma, you can imagine data points. There's a data point between here and here in terms of X, or rows, and then in terms of the columns, these commas would represent that data point. All right, so Y's, we're going to do the same thing. Our first row will remain all zeros. Notice these will plot in a little bit different spots because we're specifying the corners again, not the centers any longer. We could do a little bit of math and plot the centers, but this will show us what we're looking to learn here. All right, so now we've got our X and Y. I'm going to copy this pcolormesh cell, not change anything from it at all, and let's run it. And now we get a plot that looks like what we expect. Notice on the plot from Imshow up here, 0, 0 is the center, and it goes from -half to half. Whereas down here, because I specified 0 and 1 as the corners, it is centered at 0.5. That's that offset that I was mentioning. So you might say, well, why would I use pcolormesh? And in this instance, you wouldn't. If your data were really all equally spaced, Imshow will be several times faster. But pcolormesh gives you the versatility to not have these nice regularly spaced rectangles. We can plot oblong things or different polygons. And your mind should probably instantly jump to radar data because that is exactly what we're looking for when we're plotting radar data. All right, so now let's go ahead and create a odd-shaped X and Y array and see what we get out now. I'm not going to create something that looks like radar data. I'm going to show you that this can be very heterogeneous. So we're going to have 0, 1, 3.5, 4.5, 0, 1, 4, 5, 0, 1, 4, 5.5, and 0, 1, 3.5, 5.5 for X. For Y, we're going to have 0, 0, 0, and 0.125. So we'll have an offset for that first Y. 1, 1, 1, 1.25. So you could change as many of these and make them as odd shaped as you want, but we're just going to make some small tweaks, again, so we can really observe and think about what we're getting out. And for our final row, we'll leave it as uniform 3s. We don't need to do anything to our Z data. It is remaining the exact same. And you could copy and paste, but I'm going to go ahead and type it out again. pcolormesh x, y, z. And we'll set our aspect ratio to be equal. All right, so this definitely looks different. We can have different X and Y corners for each of these data bins. So you can start seeing how this would be really good in mapping applications with radar data, with all kinds of radially scanned data, things that aren't a model output grid. So you may say, okay, you talked about Imshow and pcolormesh, but what about pcolor? I've seen it before. There are some subtle differences between pcolor and pcolormesh. They return slightly different classes. But pcolormesh is much faster than pcolor. And I've yet to see an application where you would use just plain pcolor over pcolormesh. So ignoring those subtle differences of what's actually returned, use pcolormesh if your data are not regularly equally spaced values at a point and you're creating these nice little squares around them. Use pcolormesh if you need to define each corner of the polygon that describes the area covered by your data. I hope that you found this useful, and I'll see you on next week's MetPy Monday.